Here's where we left it. A learning loop that looks sound, guess, measure, nudge, repeat, and a history that looks damning. Networks of these nudging knobs were a known idea by the 1980s, and for decades they kept losing to simpler, hand-tuned methods. Most of the field drew the obvious conclusion, promising in theory, doomed in practice. But we've built a habit by now of not trusting the obvious conclusion. Every failure so far, we've asked, doomed or built badly. It would be sloppy to skip the question exactly once, on the failure everyone happens to agree about. So let's take the built it badly hypothesis seriously and look at how these networks were failing. And to do that fairly, we should test the learner somewhere honest. Language is awkward ground. We still have no idea how to feed a word into arithmetic. That's its own unsolved problem, and we'll face it next. But a photograph is already numbers, a grid of brightness values, no translation required. And by the early 2010s, there's a brutally public scoreboard for photographs, a yearly contest to label over 1 million photos into 1,000 categories, everything from dog breeds to espresso makers. The reigning approach there, by the way, should look familiar. Human experts hand-designed detectors for edges, corners, textures, rules about what a useful visual feature is, and fed those into a simple classifier. It's our episode 2 idea again, a person deciding, in advance, what matters. And it plateaued the same way, stuck around 26% error year after year, patches buying fractions of a percent. Now, the deep networks. Look closely at their failures, and something interesting happens. None of them sound philosophical. They were agonizingly slow. A network big enough to matter, trained on the processors of the day, took longer than anyone's patience. They were unstable. The blame signal from episode 4, passed backward through many layers, would shrivel to nothing on the way, so the early layers never learned. And they memorized. With millions of knobs and too few examples, the network learned its training photos by heart and faceplanted on new ones. Slow, unstable, memorizing. Those aren't, meaning doesn't live in a lookup table. Those are plumbing. And plumbing has fixes. Slow? Graphics processors, hardware built to do millions of small multiplications for video games, turn out to be exactly the right shape for this arithmetic, days instead of months. Shriveling signal? Use a simpler neuron, one that just passes positive values straight through, and the blame survives the trip backward. Memorizing? Randomly switch off a fraction of the neurons on every training pass, so the network can't lean on any single one and is forced into patterns that generalize. And feed it data at a scale that justifies all those knobs. That million photo pile is suddenly a feature, not a chore. In 2012, a team of 3 from Toronto entered the contest with a deep network carrying exactly this bundle of fixes. The scoreboard came back, 15% error, against everyone else's 26. The margin was so large that competitors' first assumption was that something had been measured wrong. Nothing had been measured wrong. So the verdict this time inverts, and it's worth being careful about what that means. The learning idea hadn't been failing for 30 years because it was wrong. It failed because the machines were too slow, the training tricks weren't found yet, and the datasets were too small. This is the biggest forgotten semicolon in our story, a whole field's worth of one. And it's precisely why we keep testing the boring hypothesis first, every time, even when the room has already voted. Sometimes the patch fails and the idea was doomed. Sometimes the idea was fine and the engineering it needed hadn't arrived yet. Which leaves us facing the debt we deferred at the start. The learner works spectacularly when its input is already numbers. Pixels are numbers. Words are not. Nothing about the letters CAT is a quantity. So before any of this power touches language, we owe an answer to a question that sounds almost too dumb to say out loud. What number is cat?